Placed firmly in a CNC lathe, the steel rod begins its transformation into a double-ended thread screw. The machine grips the rod tightly, preparing it for shaping. As the spindle rotates, a cutting tool moves steadily, carving out threads along the surface. The spirals catch the light, showing both depth and order. Each pass of the tool deepens the grooves, giving the screw its twin start pattern. It feels like symmetry built into steel. When finished, the screw leaves the machine, ready for industrial use with lasting strength. Steel has long been the backbone of industry, and here the story begins with its transformation into billets inside a modern facility. The sequence reveals how raw inputs are refined and cast into uniform blocks of strength and reliability. There's an undeniable sense of scale in seeing how each stage links to the next. The process opens with induction furnaces. Scrap steel and alloys are placed inside, where powerful electromagnetic currents generate intense heat. The charge melts consistently, reaching a liquid form suitable for casting. Watching metal glow in this state conveys both raw power and controlled engineering. The atmosphere in this moment feels alive, as if the entire workshop breathes with the molten steel. Next comes transfer into the ladle refining furnace. Here, chemistry is adjusted to achieve exact grades of steel. Oxygen, slag, and additives interact, reducing impurities and balancing composition. This step shows how science and machinery converge to guide molten metal toward a usable state. Operators monitor the temperature and sample the melt, ensuring quality before it moves further. You can sense the focus required as every small adjustment influences the outcome. It highlights how the smallest detail in chemistry can decide the strength of tomorrow's structures. The liquid steel then flows into the Danieli centrimet caster. Molds receive the stream, and continuous casting takes place. Water cooling solidifies the steel, gradually forming billets of uniform cross-section. It is striking how something fluid just moments ago becomes rigid, aligned, and structured. The caster's design ensures smooth withdrawal of billets, while rollers support the emerging shapes. Cutting mechanisms divide the long billets into manageable lengths. Each section is inspected, confirming surface quality and structural integrity. The clean lines and solid appearance at this stage make the results feel tangible. These billets, now complete, serve as raw stock for rolling mills and other downstream uses. The transition from fiery liquid to solid form leaves a strong impression of transformation. Throughout the sequence, the emphasis is not on spectacle, but on the controlled rhythm of production. Each stage, from melting to refining to casting, shows how industry relies on both equipment and human oversight. By the end, the billets stand as proof of consistency achieved through layered processes. Stripping thick power cables can seem daunting, yet the CST-235 makes it systematic. The process starts by fixing a 35 kV non-strippable semiconductor cable into place. Its chamfered blade cuts in one direction, leaving a neat chamfered edge. Depth adjusts 0 to 1.5 millimeters for diameters 30 to 54 millimeters. You sense the efficiency in how each cut feels controlled. Replaceable blades ensure durability. The sight of a towering CNC vertical lathe sparks curiosity about its purpose. This model, the VTL 100 CNC by Ackett, is designed for extremely heavy jobs, including a forged turntable weighing 120 tons. It's remarkable to imagine such weight resting securely on the machine's structure. The process begins with pre-filing and outer diameter cutting. Every rotation of the spindle suggests an immense force at work. The forged steel slowly takes on its intended outline, with material removed step by step. Next comes facing and chamfering. The smooth transition between surfaces adds a sense of refinement to raw power. Operators guide the sequence through CNC programming, ensuring consistency throughout. Even small adjustments influence the entire outcome. Replaceable tools maintain cutting quality over long cycles. Durability plays a critical role in continuous operation. What emerges is a balance between scale and accuracy. Lathe. Energy takes a bold route beneath the Baltic Sea. The Nord Stream pipeline is laid out as a direct link, engineered to deliver natural gas efficiently to Europe. Sections of pipe are aligned, welded, and lowered to the seabed. The project reflects collaboration and technical expertise on an enormous scale. Granules of sand are poured into a printing chamber, starting the build of an engine block mold. Layer by layer, the 3D printer spreads sand and binder, fusing shapes according to digital design. The form grows gradually, almost like a sculpture rising from dust. Once the structure is complete, excess sand is removed, revealing the complex cavity inside. It feels remarkable to see geometry so advanced, made entirely of grains. The mold is hardened, checked, and prepared for casting. Every stage carries a sense of breakthrough, blending technology with material in a striking way. At a factory floor, the production of glass-lined equipment unfolds step by step. The sequence opens as steel components are cleaned and prepped. Welders then secure the joints, ensuring even coverage of glass lining. The contrast between gleaming metal and smooth glass invites silent admiration for skill and patience. Next, components move to firing chambers, where glass adheres securely to steel under high heat. It's striking how raw materials merge to create both strength and corrosion resistance. Once cooled, each part is inspected for coating integrity, then assembled into distillation columns, reactors, or storage tanks. Finding beauty in industrial transformation is unexpectedly rewarding. A large steel sheet is the starting point for making a 200-liter semi-manual drum. They are first cut into panels and rolled to form a cylindrical body, establishing the basic shape. Welding secures the seam, locking the structure firmly. It's striking to see how raw metal gradually gains identity. Next, circular end caps are pressed into shape and fitted onto the body. Rims are added around the edges, reinforcing durability and resistance to impact. At this stage, the container already looks reliable and strong. A coating process follows, protecting the drum from corrosion and extending its service life. Additional testing ensures that each piece meets performance standards. Watching each phase flow into the next leaves a sense of steady progress. Each detail shows purpose and function working together. Bright light fills the factory as aluminum begins its journey into industrial products. The scale of production feels vast, yet every step is managed with consistency that gives the process real weight. At the very beginning, long aluminum bars are gathered and pressed together into a solid square block. This compact form makes handling more efficient and sets the base for the steps ahead. The block is then heated to the right temperature, softening the structure for shaping. Large billets are fed into extrusion presses. With immense force, the metal flows through dies to take on new profiles. The transformation here feels powerful, like strength being shaped before your eyes. It is striking how shear pressure unlocks entirely new forms. Quenching ensures stability, while stretching straightens each piece. It is fascinating how raw heat and exact control create uniformity across so many meters. Surface treatments then provide resistance against wear and enhance appearance. These treatments show how function and design stand side by side. At this stage, the aluminum no longer feels raw but refined, gaining a new identity. Finished parts are stacked and prepared for delivery. Logistics plays its role, moving products to construction, automotive, and other sectors. Heavy steel bars form the raw base for producing a strong anchor chain. Forging machines bend the steel into links, locking ends together with powerful presses. The glow of the heated steel creates a dramatic sight. Welds are sealed to ensure each link can handle extreme loads. Each segment is inspected to confirm strength before moving to the next stage. It is striking to observe how force and heat mold raw steel into functional strength. Finally, surface treatments improve durability against corrosion, completing a chain ready for harsh seas. Anchor chain production highlights engineering built to endure, linking anchors securely to massive hulls. The world of heavy industry thrives on machines that transform raw steel into usable forms. At Rottler Machine & Bow, the spotlight falls on machine tools that combine engineering power with practical applications. It feels as if every component has a role in an orchestra of metal and motion. The process begins with large roll-neck milling machines designed for shaping forged blocks. These massive units are equipped with portal structures and driven by 3 motors, each producing 120 kilowatts of power. Their task is to handle dense steel sections with accuracy and force. The sheer sound of these machines conveys strength before results even appear. By controlling the tool head, they can reduce uneven surfaces and deliver standardized forms required for rolling mills. Next, modernization of portal-type milling machines ensures efficiency for long-term service. Here, forged steel blocks are guided into position under portal frames that move with stability. With 137 kilowatts driving power, they manage rail machining and similar large-scale steel applications. Observers often pause at the sight of glowing steel being refined under such controlled movements. The production line also features the saw milling machine SFQ60. This system combines sawing and milling in one continuous operation, saving time while reducing handling. The design reflects adaptability, as it can cut and shape steel blocks for further processing. One can sense the advantage of combining two actions in one streamlined setup. Attention then shifts to turning machines, such as the DBR 700 2000 round bar lathe. These machines rotate large cylindrical parts, removing material gradually to create smooth profiles. Their versatility allows for various diameters and lengths, supporting different steel components. Each rotation tells a story of transformation from rough to functional. Another highlight is the planer type machine with a movable column, the BFZ 130 to 40 NC. Its configuration permits complex surface machining while maintaining consistent tool contact. Such systems exemplify how design and performance meet production demands. The alignment of structure and function feels almost poetic in industrial form. In every step, planning, construction, assembly, and retrofitting define the company's approach. The outcome is machinery that not only cuts steel but also extends possibilities in industrial manufacturing. Even without technical knowledge, one can appreciate the intensity and rhythm of this environment. The process of creating strong copper wire begins with the rigid frame stranding machine 90B, built to align multiple strands into a single cable. Its design feels solid, giving confidence in every rotation. First, reels of copper are placed onto the machine's frame. The strands are pulled evenly, preventing uneven stress. Next, the rigid structure guides each layer into a consistent twist. The steady movement has a rhythm that is almost calming. Finally, the finished cable exits the machine, compact and uniform. One can sense the strength locked into every strand. This sequence demonstrates how copper becomes durable wiring for industry. In a compact workshop, the 2-meter manual bending machine demonstrates its solid build and durability. The operator places aluminum sheets onto the folding table, supported by a foldable rest for larger pieces. With steady motion, the upper beam adjusts in height, aided by a gas spring. The angle scale guides accurate bends, even in repeated production. A rolling shear, included with the unit, expands capability by cutting sheets efficiently. It feels robust, offering reliability with every movement. The journey of large-diameter, seamless steel pipe begins with steelmaking, where high-purity oxygen reacts with carbon and impurities to create stronger, cleaner metal. This step ensures the durability required for pipelines and construction. Oxygen blowing into electric furnaces not only maintains heat, but also shortens smelting time. PKU Pioneer's VPSA oxygen unit supports this process with efficiency. The scale of transformation is impressive, showing how steel evolves into reliable infrastructure material.